Imagine you are an early career engineer tasked with debugging a critical production failure in a complex distributed system. The clock is ticking. The cost of running your debugging tools is eating into your budget. For years, the only answer was to pay a premium for proprietary models that promised to solve these impossible puzzles. But the landscape is shifting beneath our feet. We are witnessing a moment where open alternatives are not just catching up, but are actively redefining what is possible. Today we are looking at a specific claim about DeepSeek V4, a model said to be almost on the frontier, yet priced at a fraction of the cost of its competitors. Before we dive into the specifics, let us clarify what we are actually talking about. The narrative around DeepSeek V4 is compelling, suggesting a model that matches or surpasses top-tier systems like GPT-4o and GPT-5 in reasoning, mathematics, and coding. The promise is that you can perform production-grade refactoring and system design debugging without the prohibitive costs that usually accompany frontier-level intelligence. This would be a massive disruption. However, the reality on the ground is slightly more nuanced than the headlines suggest. While the R1 and V3.2 iterations have already proven they can match the best in the world, the existence of a verified V4 model remains a point of active discussion rather than settled fact. Here is the thing. Even if the specific version number is still evolving or being conflated with the R1 variant, the underlying capability being discussed is real. The research indicates that DeepSeek has successfully deployed architectural innovations like mixture of experts and sparse attention. These are not just buzzwords. They are the mechanical levers that allow the model to achieve high performance while using significantly fewer computational resources. Think of it like a library. Instead of every single librarian knowing everything, the system routes a query to the specific librarian who knows the answer. This sparsity means you do not need to run the entire massive engine for every single question, which is where the cost savings begin. Now consider the practical implications for someone building a startup or maintaining legacy code. The traditional model of generative AI required you to pay a premium for every token processed. If you were running a complex refactoring task on a large codebase, the bill could spiral out of control. DeepSeek challenges this assumption directly. By delivering capabilities comparable to the most expensive closed models at a fraction of the price, they are effectively breaking the pricing paradigm. This is why we are seeing a rapid displacement of established players in the app stores. Users are not driven by brand loyalty anymore. They are driven by value and capability. If you can get the same result for 10% of the cost, you are going to switch. The stress tests we are looking at involve complex system design debugging and production-grade refactoring. These are not simple chat tasks. They require the model to understand dependencies, trace errors through multiple layers of abstraction, and propose solutions that do not introduce new bugs. In these scenarios, the DeepSeek models have shown they can hold their own against the giants. They can analyze a failing microservice, identify the race condition, and suggest a patch that respects the existing architecture. This is the kind of work that used to require a senior engineer with years of experience. Now, it is becoming accessible to anyone with a budget. Of course, no system is perfect. Some comparative studies note that while DeepSeek excels in reasoning and coding, there are still specific classification metrics where it may trail behind competitors like Claude. There are also reports of slightly slower inference speeds in certain contexts. This is important context. Speed matters when you are waiting for a response during a live incident. However, for deep analysis and batch processing tasks, the trade-off often favors the cost and reasoning depth that DeepSeek offers. The gap is closing, and the direction of travel is clear. A quick note here. Explore interesting tech and builder resources in the description. Let us return to the core of the issue. The emergence of these models is forcing U.S. competitors to reconsider their proprietary strategies. When you have an open, high-performance, and affordable alternative that matches the best in the world, the value proposition of keeping your model closed changes. It creates a feedback loop. As more developers adopt these open models, the community builds more tooling around them. This tooling makes adoption even easier, which in turn drives more adoption. It is a cycle that benefits the entire ecosystem. For the early career engineer, this is a game changer. You no longer need to justify expensive API calls for every small task. You can experiment more freely. You can refactor larger codebases without fear of the bill. You can learn from the outputs of a model that is capable of deep reasoning. This democratization of high-level intelligence is what is truly happening here. It is not just about saving money. It is about lowering the barrier to entry for building complex software systems. The research also points to a broader shift in the industry. The assumption that frontier-level performance requires prohibitive costs is being dismantled. DeepSeek has shown that with the right architecture, you do not need to burn billions in training costs to achieve top-tier results. This opens the door for more innovation. If the cost of intelligence drops, the applications that can be built with it expand exponentially. We are likely to see a new wave of tools and services that were previously too expensive to develop. So, what does this mean for the future of software engineering? It means that the distinction between open and closed models is becoming less about capability and more about ecosystem and support. The technology itself has leveled the playing field. The models are capable of handling the most difficult debugging tasks and complex refactoring work. The cost is the variable that has changed. For those of us watching from the sidelines, it is a reminder that the most powerful tools are often the ones that are most accessible. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.